Unit 3, Lesson 8, Graphing Log Functions. And we're going to be exploring the value of b in the equation y equals log x to the base b. So b is actually the base value of this log function. Notice that every graph of this form must pass through the point 1, 0, because when x is 1, log of 1, no matter what the base is 0. You can try that on your calculator with your log base 10, so log 1 base 10 you'll see is 0. So part 1, graph. The graph of y equals log x base 3 is shown. The graph passes through the point 3, 1 because log 3 base 3 is 1. In each of the following, complete the statement and sketch the graph on the grid using a graphing calculator with this window format. So your x minimum maximum and scale, your y minimum maximum and scale. So you want to go into window and put these values in. So in completing the statements, y equals log x base 10, if you think when x is 10, then log 10 base 10 should equal 1, a y value of 1. So when x is 10, y is 1. And if you graph these on your calculator, you'll get these graphs, all these graphs. You can put them all in if you want, or one at a time. Log x base a third. Now if the base is a third, then obviously if x is a third, y will be 1. So when x is a third, y is 1. What if it's log x base 1 over 10? So if x is 1 over 10, then this whole thing will become 1, a y value of 1. So without using a graphing calculator, make a sketch of the graphs of the following and verify with a graphing calculator. You can figure out some points. You know that when, let's see, log of 1, when x is 1, this whole thing becomes 0. Log of 1, as it said above, and no matter what the base is always 0, so that gives you 1 point. And the other point you can have is if you have x equal to 5, log 5 base 5, y would be 1. So that gives you 2 points. And then I guess you can change this to say 5 to the 2. If the x is 5 to the 2, then bringing the 2 to the front, when x is 5 to the 2, in other words, when x is 25, the value of all of this, y, should be 2. Over here, if x is 1, y will be 0. If x is a fifth, y will be 1, and so on. You could look at x to be 1/5 to the exponent 2, and then you can bring the 2 forward. So 1 to the 5th to the exponent 2 is really 1 over 25. When x is 1 over 25, then y will be, it seems that y will be 2. So very small, when x is very small. So that's why when x is very small here, values of x being very small, close to the y-axis, the value of y increases. So below completing the table, let's have a look at that. Okay, so if these are the functions, log x base 3, the value of x has to be greater than 0 for any logs. For logging a number, it has to be greater than 0. After that, as long as it's greater than 0, x can be any kind of real number. What is the range? Well, notice the range goes up here and then down, so it covers all real numbers. Or if you look at these ones, it will go all the way down never crossing the y-axis, and then increase. X-intercept, well, the x-intercept's always at 1, 0, so always at 1. Y-intercept, it never crosses the y-axis, as long as it's in this format. In other words, as long as it's log of a number. If we put log of, and we had a bracket here, x minus 1, then it would shift the graph to the right. If it was x plus 1 in brackets here, it would shift the graph to the left. So yes, that would make a difference. But in this case, there is no y-intercept. The asymptotes are the y-axis, which has the equation x equals 0 for all of them. And then, what is the x value when y is 1? What value of x do you need to make y 1? Well, in this case, as long as x is 3, y will be 1. If x is 10, y will be 1. If x is a third, y will be 1. If x is a tenth, y will be 1. If x is b, y will be 1. So that's where these values here come from. Now looking at the graphs of log x base 3 and log x base a third, how do they compare? Well, notice they are a reflection in the x-axis. This value here, or this value here rather, is really 3 to the negative 1. So the base value has become 3 to the negative 1. In other words, a third. Okay, what does that mean? Well, if you put this in exponential form, drop the x down, swing the third over, and bump the value up, then let's have a look at that. You would get x, okay, just one sec while I pause this and move this back. Okay, so comparing these two, a reflection in the x-axis. So let's just look at the graph above. You can see they are a reflection in the x-axis. And it's saying, how do these two compare with each other? Well, again, it's a reflection in the x-axis. So if you change the base from 10 to 1/10, or from b to 1 over b, this is what's happening. So the graph of y equals log x base 1 over b is a reflection in the x-axis of log x base b. In the transformation unit, the replacement for a reflection in the x-axis was y changed to negative y. Starting with this formula, make this replacement to determine the equation of the graph reflected in the x-axis. Well, notice this is what we're starting with, and if we change y to negative y, which this sort of seems to imply, and going from here over to here, this is what we're seeming to do. So let's do that. Let's change y to negative y and plug it in here. So we get this. Okay, and now what about this negative? This negative can be transferred over here. So over here. And it seems that, therefore, this equation must be similar, or must be equal to log of x to the 1 over b. So that's what it's saying here. We've now got two equations for the graph of log x base b. It can either be written as this or as this. Okay. So down here I've written why this is so. If you look at this negative 1 and bring it up, actually let's just put this log x over log b. So here's log x over log b, but we're putting the negative down here instead of up above. When we do this, we can bring this negative, really negative 1, up as an exponent with b. So we have log x over log b negative 1, but log b negative 1 is really 1 over b. Now in this format, you can see that this equation here, this is really going to be the base number. It will be equivalent to this here. So we can write this equation as this. Okay, so if log x base 4 equals 8, state the value of this. So remember, that just means it's the negative of this. So it's really negative 8. See, this equals negative 8. So changing from 4 to 1 over 4 changes this value to a negative. Prove the result in A by converting to exponential form. So if we want to convert to exponential form, we do drop, swing, bump. We drop, swing the 4 over, put the 8 up. If we have log x to the base 1/4, we can drop, swing, bump, bring the x down, swing the 1/4 over, and bump the v up, whatever this value is. Now, of course, we know already it's negative 8, but we're trying to find out what it is. Well, a quarter is really 4 to the negative 1, so it means this whole thing is 4 to the negative v. So, we're having to say that if x is this here, we don't know what v is, don't know what this value is, we're trying to figure it out, and x is 4 to the 8. If we want this guy here to equal this guy here, it means that the value of x on this side has to be the same value on this side. So we can make this guy equal to this, and in doing that we're going to solve now for v. So solving for v, we can see that this would have to be, v would have to be, or negative v has to be 8, so v has to be negative 8. So v is negative 8, and back up here we can see that this whole thing is a negative 8. Just take a minute to look through that, as that can be a little bit confusing. The way I looked at it above is probably a better way. The way I described it above is probably a better way to look at it, I would think. Alright, part 2 of this lesson. The partial graphs of log x base 2 and log x base 4, log x base 8 are shown. Remember, these are really, this is really 2 to the 2, and this is 2 to the 3. So what does that look like on a graph? And you can see that as the base number increases, then this tends to flatten out. And notice the drop from here to here, and then here to here it's not so much. Yeah. Complete the following statements. 1. Yx base 2 passes through 8. If x is 8, then this is really 2 to the 3. The 3 comes over, so y would equal 3. And this one, if x is 8, this becomes again x to the, 2 to the 3. The 3 comes over, but we really want this to be a 4. Can we write this as a 4? Log 4, and this be a 4. Now if x is 8, 8 is 4 to the what? We'd have to square root it. Yeah. What does 8 equal? It's 4 square rooted and then cubed. So we can write that as 4 to the 3 over 2. So this is 4 to the 3 over 2. And the 3 over 2 can be brought to the front. So if x is 8, it really is 4 to the 3 over 2. 3 over 2 can be brought to the front, and that would be the value of y. If x is 8, obviously log 8 base 8 is 1. The graph of y equals log x base 4 is a vertical stretch of the graph of log x base 2 about the x-axis. State the stretch factor and complete the statement. Well, we can see that in going from here to here, what's happened, the vertical stretch. State the stretch factor and complete the statement. Well, it's really a half. Log x base 4 is really a half log x base 2. So the stretch factor would be a half. So no, in going from 3 to 3 over 2, we've just basically divided this by a half in going from here to here. The graph of log x base 8 is a vertical stretch of the graph of log x base 2 by what amount? Well, notice we've gone from 3 to 1, so we've really divided this by 3. So 3 has gone to 1, so it's a vertical stretch by a factor of a third. Use the results above to determine the transformation, which would map the graph of log x base 2 to the graph of log x base 64. Well, 64 is really 2, here it is over here, 2 to the 6. So it would be, the stretch would be a vertical stretch by a factor of 1/6. So the above is an example of a general rule. When we have log x base b, log x base b to the n, see the n here, okay, it's a vertical stretch about the x-axis by a factor of 1 over n, whatever this exponent happens to be. And we also know therefore that log x base bn has to equal 1 over n times log x base b. So please make a note of that. So at this point I'm going to split this video into 2 parts for this lesson, and I'll carry on in the next part.